Hello everyone and welcome to the lecture on Amazon EC2 auto scaling. So this lecture will contain all these topics. What is Amazon EC2 auto scaling? Features, auto scaling group example, Amazon EC2 auto scaling benefits, cover variable demand, typical web app architecture, distribute instances across availability zones, auto scaling launch templates, auto scaling methods, set scaling limits for your auto scaling group, elastic load balancing with auto scaling, use event bridge for auto scaling events. So what is Amazon EC2 auto scaling? Amazon EC2 auto scaling ensures that you have the correct number of Amazon EC2 instances available to handle the load for your application, effectively managing your application's capacity. Auto scaling groups are collections of EC2 instances that you create to manage your application's scaling needs. Amazon EC2 auto scaling provides comprehensive group size management. It ensures that your group never goes below the specified minimum number of instances. It guarantees that your group never exceeds the specified maximum number of instances. It maintains the desired capacity of instances, which you can set when creating the group or adjust at any time. With scaling policies, Amazon EC2 auto scaling dynamically adjusts the number of instances. It can launch new instances when the demand on your application increases. It can terminate instances when the demand on your application decreases. Features of Amazon EC2 auto scaling. Auto scaling groups. With Amazon EC2 auto scaling, your EC2 instances are organized into auto scaling groups so that they can be treated as a logical unit for the purpose of scaling and management. Auto scaling groups use launch templates or launch configurations. Launch configurations was the first older technologies. Now we use for most of that we use launch templates, which is like version 2. So we use launch templates as configuration templates for their EC2 instances. Monitoring the health of running instances. Amazon EC2 auto scaling automatically monitors the health and availability of your instances using EC2 health checks and replaces terminated or impaired instances to maintain your desired capacity. Custom health checks. In addition to the built-in health checks, you can define custom health checks that are specific to your application to verify that it is responding as expected. If an instance fails your custom health check, it is automatically replaced to maintain your desired capacity. Balancing capacity across availability zone. So you can specify multiple availability zones for your auto scaling group, and Amazon EC2 auto scaling balances your instances evenly across the availability zones as the group scales. This provides high availability and resiliency by protecting your application from failures in a single location. Multiple instance types and purchase options. Within a single auto scaling group, you can launch multiple instance types and purchase options, which can be a mix of spot and on-demand instances, and that allows you to optimize cost through spot instance usage. You can also take advantage of reserved instance and savings plans discount by using them in conjunction with on-demand instances in the group. Automated replacement of spot instances. So if your group includes spot instances, Amazon EC2 auto scaling can automatically request replacement spot capacity if your spot instances are interrupted. Through capacity rebalancing, Amazon EC2 auto scaling can also monitor and proactively replace your spot instances that are at an elevated risk of interruption. Load balancing. You can use elastic load balancing and health checks to ensure an even distribution of application traffic to your healthy instances. Whenever instances are launched or terminated, Amazon EC2 auto scaling automatically registers and deregisters the instances from the load balancer. Scalability. Amazon EC2 auto scaling also provides several ways for you to scale your auto scaling groups. Using auto scaling allows you to maintain application availability and reduce cost by adding capacity to handle peak loads and removing capacity when demand is lower. You can also manually adjust the size of your auto scaling group as needed. Instance refresh. The instance refresh feature provides a mechanism to update instances in a rolling fashion. when you update your AMI or launch template. You can also use a phased approach known as a canary deployment to test a new AMI or launch template on a small set of instances before rolling out to the whole autoscaling group. Lifecycle hooks. Lifecycle hooks are useful for defining custom actions that are invoked as new instances launch or before instances are terminated. This feature is particularly useful for building event-driven architectures, but it also helps you manage instances through lifecycle. Support for stateful workloads. Lifecycle hooks also offer a mechanism for persisting state on shutdown to ensure continuity for stateful applications. You can also use scaling protection or custom termination policies to prevent instances with long-running processes from terminating early. Autoscaling group example. So for example, the following autoscaling group has a minimum size of 3 instances, a desired capacity of 5 instances, and a maximum size of 9 instances. The scaling policies that you define adjust the number of instances within your minimum and maximum number of instances based on the criteria that you specify. So when this autoscaling group is started, it will start minimum with 3, then it will come to 5. So it will keep desired as 5. So it will try to keep running. So this 3 must be launched. Otherwise this whole autoscaling group will be in an unhealthy state. But desired is what we want for optimal running of application. So it will keep till 5. It will go only to 3 when there is like a constraint in terms of capacity from the AWS side itself. And so it will keep 5 when the traffic increases or the CPU load or memory increases. So you can monitor that, and based on those monitoring you can scale out. Scale out means you will expand the capacity. So it will add one by one extra till 9, but it will not go 9. So that is kind of a safety mechanism so that you don't overrun your cost, and when the traffic reduces it will scale in. So just remember, scale in is like shrink, so it is going inward. Okay, EC2 auto scaling benefits. So better fault tolerance. So Amazon EC2 auto scaling can detect when instance is unhealthy, terminate it, and launch an instance to replace it. You can also configure Amazon EC2 auto scaling to use multiple availability zones. If one availability zone becomes unavailable, Amazon EC2 auto scaling can launch instances in another one to compensate. Amazon EC2 auto scaling helps ensure that your application always has the right amount of capacity to handle the current traffic demand. Amazon EC2 auto scaling can dynamically increase and decrease capacity as needed because you pay for the EC2 instances you use. Thereby you save money by launching instances when they are needed and terminated them when they are not. So covering variable demand. So Amazon EC2 auto scaling offers this solution to the challenge of managing variable demand for web applications running on AWS. So for example, this scenario involves a conference room booking application with fluctuating usage patterns throughout the week. Traditionally, businesses face 2 suboptimal choices. First one, over provisioning resources to always meet peak demand, which results in wasted capacity and increased cost. So this is the typical usage, actual capacity that is required to run the business. Then what will you do? So first scenario is you will provide CPU, memory, storage, whatever is provisioned. So this will make sure that application runs smoothly, but it will cost you a lot because there is a capacity which is unused. Or second problem is under provisioning. So or provisioning for average demand. So you just provision for average, you take an average, you put an average, but this is fine for example 4 days, but the 3 peak days this is under capacity. So what will happen? You will have bad customer experience or user experience, which will finally also result in losing money or losing your business. Then EC2 auto scaling introduces a third, more efficient option, which is here, and this feature dynamically adjusts the number of EC2 instances based on the real-time demand. It adds new instances when necessary and terminates them when they are no longer needed. This approach ensures optimal resource utilization, maintaining a balance between cost effectiveness and performance. So this is a typical web application architecture, and it is within one availability zone. So think of as one single data center, So in a common web app scenario, multiple copies of the application run simultaneously to handle the volume of customer traffic, ensuring efficient service delivery. These multiple application copies are hosted on identical EC2 instances, which are cloud servers that process individual customer requests. Amazon EC2 auto scaling manages the launch and termination of EC2 instances based on defined criteria, such as Amazon CloudWatch alarms, automatically adjusting the number of active instances. So this is a web server fleet, this is app server fleet, and this will just spin up when the traffic demand increases. So we can see the benefits are increased availability and fault tolerance. So this is we are introducing load balancer here and here between two layer also. So implementing auto scaling groups in the network architecture enhances the application availability and fault tolerance. The system offers flexibility which allows for the creation of multiple auto scaling groups. So this is also part of one auto scaling group and another auto scaling group, with the option to dedicate a group to each tier of your application. To optimize traffic distribution among instances in the auto scaling groups, a load balancer can be incorporated into the architecture, ensuring balanced request handling. So this is part of auto scaling group, all these 5, but it is desired is 3, and these two will spin up because of the auto scaling maximum capacity, and this one is above the auto scaling group. So elastic load balancer will direct traffic to the auto scaling group, and that in turn will send the traffic to the backend EC2 instances. So distribute instances across availability zones. So what we have seen is single region and single AZ. Now we are talking about multiple AZ and distributed application within a whole region. For example, US East 1, North Virginia 1, North Virginia. So that is a whole region. And these are like multiple AZ, and they are like a group of one or more data centers. So availability zones are isolated locations within an AWS region with multiple AZs per region, designed to provide high availability. Each AZ is identified by the AWS region code followed by a letter identifier. For example, US East 1A. So that is a AZ. Using multiple AZs increase application availability and provides independence between zones, enhancing the overall resilience of your application. When creating a custom VPC and subnets, you can define one or more subnets in each availability zone. However, each subnet must reside entirely within one AZ and cannot span multiple availability zones. So this is one subnet, one subnet, one subnet. So it cannot expand to another. So this one subnet is part of one AZ, and herein you have one more tier, and this is also part of separate AZ. So this web tier have 3 subnets and in each availability zone, and this application tier also has one subnet in each AZ. So this is the typical architecture of a distributed application across multiple AZ and in a single region. So when creating an auto scaling group, you must choose the VPC and subnets for deployment. Amazon EC2 auto scaling creates instances in your chosen subnets. So it will whichever subnet you specify, it will create in those only, associating each instance with a specific availability zone. Amazon EC2 auto scaling aims to evenly distribute instances across the chosen availability zone when launching, promoting high availability and reliability for your application. So there is a feature like multi-AZ distribution. So it will make sure that it launch first in first AZ, then another in another AZ, then it will go to the third, then again it will continue from the first, second, third. So it will not go ahead and create multiple here and not utilize the other 2 AZs. So next topic is auto scaling launch templates. Launch templates specify instance configuration information, which includes AMI ID, Amazon machine image, instance type, key pair, security groups, and other parameters for launching EC2 instances. Unlike launch configurations, launch templates support multiple versions. So launch configuration, as I talked about, is an older technology. Now nowadays we just use launch template, and this supports versioning also. So versioning benefits. So versioning of launch templates allows creating subsets of parameter that can be reused for other versions. For example, you can create a base configuration without an AMI or user data, then add this in a new version for testing. This approach helps maintain general configuration parameters and allows easy creation of new versions or deletion of test versions. Launch templates offer more features than launch configurations. For instance, launch configurations cannot create auto-scaling groups with both spot and on-demand instances or specify multiple instance types, while launch templates can configure these features. Launch templates provides access to newer EC2 features, including systems manager parameters like AMI ID, EBS provisioned IOPS volumes IO2, EBS volume tagging, T2 unlimited instances, capacity reservations, capacity blocks, and dedicated host. When creating a launch template, all parameters are optional. However, if no AMI is specified, you cannot add one when creating an auto-scaling group. If an AMI is specified but no instance type, you can add instance types when creating the auto-scaling group. So let's see some auto-scaling methods. First one is maintaining a fixed number of instances. So you keep your auto-scaling group at a constant size, replacing unhealthy instances automatically to maintain desired capacity. Second, you directly adjust the desired capacity of your auto-scaling group or terminate specific instances as needed for immediate control. Third, automatic scaling action based on the predictable demand patterns, aligning resource availability when expected traffic. You can utilize scaling policies to automatically adjust capacity in real time, ensuring optimal performance amidst fluctuating demands. And you can combine predictive and dynamic scaling to proactively adjust resources ahead of anticipated traffic patterns, ensuring readiness for both daily and weekly fluctuations. For example, some yearly events, for example Black Friday and all, so you know in advance, so you can proactively adjust the scaling, and you can set some kind of dynamic scaling to adjust to that. So you can change the auto scaling group maximum size, because you know in advance that time the demand can increase. So let's say you are running with 10, so that time maybe you can adjust the max size to up to till 20, 30, whatever is required as per the business needs. Setting scaling limits for your auto scaling group. Minimum and maximum group size. This defines the boundaries for the size of your auto scaling group, ensuring operational flexibility with predefined limits. Desired capacity management. This specifies initial group capacity at creation, which is aimed at maintaining this level barring scaling policies or scheduled actions. Minimum capacity constraints. So this ensures scaling policies do not reduce the group's size below the minimum set limit, safeguarding against inadequate resources. Maximum capacity constraints. This prevents scaling policies from exceeding the group's set maximum size, controlling resource overutilization. The ability to adjust the group's desired capacity manually or through scheduled actions within the set limits. Automatically launch. So auto recovery of desired capacity. This automatically launches new instances to maintain desired capacity in case of unexpected terminations, ensuring resilience and continuity. Elastic load balancing with auto scaling. So first one is automatic traffic distribution. It distributes incoming application traffic across all EC2 instances evenly, preventing any single instance from being overwhelmed. Attach load balancer to auto scaling group. This simplifies setup by acting as a single point of contact for incoming web traffic, enhancing efficiency. No manual instance registration needed. The instances launched or terminated by the auto scaling group are automatically registered or deregistered with the load balancer. Use elastic load balancing matrix for scaling. This allows for dynamic scaling of instances based on demand, utilizing elastic load balancing matrix like the application load balancer request count. Optional ELB health checks. This enhances reliability by enabling Amazon EC2 auto scaling to identify and replace unhealthy instances based on load balancer health checks. Event Bridge, which is a service that monitors resources and initiates actions using other AWS services based on rules. Events from Amazon EC2 auto scaling are delivered nearly instantaneously, which allows for timely responses. You can create rules in Event Bridge that invokes actions or notifications in response to EC2 auto scaling events, like launching or terminating instances. Event Bridge rules can target AWS Lambda functions, Amazon SNS topics, API destinations, event buses, and all the targets supported by Event Bridge rules, and that facilitates a diverse set of responses to events. So basically, EC2 auto scaling events can be sent to Event Bridge, and Event Bridge will just consume that, and all the targets that are supported by Event Bridge, you can invoke that in response to event that you get. So based on launch or terminate, or based on the lifecycle event hooks, you can do whatever business requirement. So you can send to Lambda, SNS, API, or event buses, and those event buses can send to other partner or other SaaS applications. So something like Datadog or PagerDuty. So you can take whatever actions you feel like. And that's all. Thanks for watching.